Alright, type we're back in chat. Nat to U size, wink. Oh, nat.to-u size. Are we back?
Yeah, can you hear us?
Can you see us? With our infinity mirror. Oh, look, there's...
Yep, much better.
Yeah, we just had to stop stream and start stream once we got all those CPU resources freed up.
Well, then I think I can
Alright,
go
so
back
we
to
killed Cursor. Cursor is... No, don't restart Cursor. It's just gonna do the same thing again. No Cursor. We're gonna do it live. We're gonna do it like the pioneers did. In the ancestral environment.
Fine.
In Neovim. Neovim is way more advanced than what the pioneers did in the ancestral environment, by the way. In the ancestral environment, the pioneers were in Emacs. No, I'm goofing. I love Emacs.
It's processing. Not busily though. It's slacking.
Yeah, right.
Right.
But the usage is spiking again.
Yeah, I think that would be from OBS, which is fine.
Right. What would it be though? Neovim is also spiking a little bit, more so.
Not that
because.
So wait. I'm killing Xcode and Simulator because they shouldn't even be on right now, and they're hogs. They're doing some reaping for resources. I'll keep rewind going. Despite recording, it really doesn't take as many CPU resources as I would expect. Like, there's the occasional spike.
Yeah.
But then it drops, and it's like, fine, they can drop a frame.
Okay, so wait, we should read Thomas's comment in Zulip.
The one about lean calls.
Yeah, what is lean calls? No, it's not the DMs. It's in general. By Einops, you mean Einstein notation? Yes, we mean Einstein notation, right? So what is lean calls? What is lean calls?
I'm assuming it's a collection library that's probably been written like recently.
Oh.
Sort of recently. General purpose collections library. See notes for
implemented in pure lean 4.
The philosophy is making me think of something John Arbuthnot said, which is funny but not true. Good defaults, generics.
Could use typecast resolution to pick among implementations. Code obfuscation. Performance altering decisions should be explicit. Okay, great. These are nice.
Agda, very category theory.
Very ... category theory.
According to this, there's not a correct by construction library. I can live without it being correct by construction.
Yeah, what did correct by construction ever do for me? What have the Romans ever done for us? No, I hear you. But yeah, can I read the comment again? Refactoring silent. I'm in the process of refactoring silent, which supports n-dimensional array notation. Okay, so let's like chat with Thomas like in Zulip, not in chat. Okay, wait. General interfaces for collection. Silence array type is called indexed in lean calls. Wait. So, but you're talking about doing lean calls as a dependency in Silene, not the other way around.
He's saying just implement it for lean calls and forget Silene for now.
Oh, just for lean call. Oh, yeah, that makes sense because Silene gets you all into like the bits and the bytes and everything to get the
and the boops.
So I was just thinking about the types though of like using for our matrix for our tensor type, using the IDX enums and everything.
Hey Thomas, is there stride in lean calls? Well, nothing's happening.
Yeah, why don't? Well, we can't index it because we can't. Now I'm like, I'm already pilled, dude. I'm already cursor pilled. This is a disaster.
You cursed. Well, let's do this. Let me just close one of these.
Oh, you had 2 open?
Yeah, and then I will index it because you can't stop me. I will download the internet. I will not be on it. And we're off to the races.
Okay, but just watch your usage up there.
It's a
Okay,
dangerous-
so
Oh, right. Yeah.
what do you mean by stride? Oh, stride is in like you represent a tensor as a 1D array, and then you mark the strides, which tells you like every X steps, like flip it, grab the next N elements and turn them into the next row. You know what I mean? Like stride is in. I thought that was the term for it in array implementations and in matrix implementations. In fact, when we were talking to AI about a NumPy's implementation, that's the word they use too. So stride is in like Einops calls. What's that?
I'm just making a fresh repo
Oh yeah.
and just adding to like, just keep talking.
Okay, yeah. So yeah, all I mean by stride is I see. The idea is to use index type that gives you the equivalence between some structured type and fin n.
Is there a way for him to give video?
I think it's hard to set up. If actually no, if you just open up like a Google Meet or something, we could
some
just.
like weird recursive shit.
There might be some weird recursive shit that happens.
No, 'cause there's
No,
no
you can do
connection
it.
between Google Meet and Twitch, so it's fine. Hey Thomas, you want to talk?
Yeah, if you want to come on stream, dude, like we could talk this
I'm
out.
not sure he does, but
If it's not a good time, absolutely, then don't. But yeah. But anyway, that's cool. Your comment that I read briefly before it disappeared in the corner.
oh, nailed it.
Sure, no problem. All right, let's whip up a Google Meet. Start an instant meeting. Ooh.
Yes. Well, anyone can join, I guess, because it's right there.
Why am I
I-
thinking thumbs up? Here, exit the
Down.
thing.
I don't know, man. Anyway,
Hey, wait, do you want to DM him that? Never mind,
No.
it's too late.
we're working in public, aren't we?
We are working in
This is
public.
literally being live streamed.
It's literally being live streamed. No, you're good. Here, I have the. Yeah, makes sense.
Okay.
Yeah, so.
Yeah. Admit. Hey. Nice
Hey, Thomas. Oh, wait, we don't have your audio, dude.
We're about to, though. Hang on.
Now you can hear me, right?
Oh,
Yes.
yeah, now we can hear you. Yeah.
Okay. Yeah, I should also toggle, like, mute the Twitch.
Yeah.
Okay, cool. Nice to meet you. I already met Alex.
Yeah, good to meet you. Here we are, live on Twitch, live on Alok's Twitch stream, Twitch channel. Yeah, so we've been enjoying the Silene take and like reading through the code and everything. There's definitely a lot there, but you're recommending to do it from the perspective of the lean calls, the collections, and that makes sense. Go ahead.
Yeah, so there's a bunch of stuff I think I haven't done in Silene, which James did, and he kind of like tries to prove everything, and I'm not bothered proving everything, so I think like if someone will do it, then I'll just reuse it.
Very mathematician.
And, yeah, and I think like for the matrices and stuff, right? The idea is that matrix is nothing but like some
Index
function
map.
from some structured index, structured index to like floats or real numbers or whatever.
Yep.
Right?
Yep.
So you don't really have some kind of like so instead of stride, I think that already it's called in lean calls, there is something called index type, which is exactly in Silene you had the even type. That's the same thing. It's effectively a type that has like one-to-one mapping between pin n for in a
Yeah.
place n,
Or an Einops.
and you use this map to exactly kind of linearize indices. So if you have a tensor of rank 3, then you just create a triple of numbers, and then use the index type to map it to like just a one number.
I mean, I like that to some degree. What I like about being able to use, we might want to do like list of different index types that can be different sizes, arrow to element, instead of doing like for like a rank 2 tensor, do ix like index type for x's, arrow index type for y's, arrow elements. K, because like in a functional model of matrices, you want to do it like functions from some enumerable type, for sure, which is different from the implementation detail, but if you want to do something for more performance. But I agree with that. However, one thing I don't like is, like, in my experience with type theories, and maybe Lean is different, it's a pain in the butt to like meta program to like arbitrary like variable lengths of arguments unless you're like uncurried or something. So I would want to do the uncurried version where it's like list of IDX of items, arrow, elements, because the curried version you wouldn't be able to have a dynamic way of saying like. Or maybe you would. Maybe you could do it without too much headache.
No.
So 4 gigabytes.
So exactly the approach I do right now for matrices, that matrix is effectively something that has correlation to a function that goes from product of pin m to like a real number.
Yeah. That's a great matrix.
Right.
My problem is with arbitrary ranked tensors, and if I go from a rank 3 tensor to a rank 4 tensor, then how do I change the signature? That's like metaprogramming in a type theory. That's my view.
Yeah. So let me think. So let me see if I actually have saline right now. Or maybe it's like half broken. Um, let me check. Because I already have like in saline I have like effectively tensors of
What do you use
arbitrary
Copilot to
range.
fix my main
Working. So you can definitely already do that.
Okay. Yeah, if you think it's not too much of a headache, or it's already done even, then I retract my objection.
I think there is a certain thing. Yeah, I don't think. I'm just thinking now. There is definitely a certain problem to have like a function which is completely dynamic on the rank, or in some way the rank of a tensor is not fully well defined.
Okay.
Because like for example right now you can think about it like, so if you have rank 3 tensor right now, so you can think about it also as a rank 2 tensor where the first dimension is indexed by a single number and the second dimension is indexed by pairs of numbers.
Oh, right, yeah, that's one way of doing it.
Oh,
where
yeah,
every
so
tensor is a rank 2
it.
tensor and you recursion it.
Yeah.
Oh, that's a reasonable. Is that reasonable? Do I like that?
How should I know what you like?
I don't know.
I mean, I have plenty of ways to know. I think you like it, yeah.
So in my experience, it's really, really nice to have the index the indices of the matrices and tensors, they can be like effectively any kind of finite type, because quite often you build in a matrix which some properties, right? And the indices, they have some meaning, right? They, I don't know, you can index
Yeah.
by
Have you seen X-Array?
X-ray, no.
Okay, take a look at that, because X-Array is the single most famous implementation of like the semantic part of your idea. Certainly not how they implemented it, because it's all in Python for one thing.
Mm-hmm.
But the idea of a labeled array, and in particular, restricting operations as much as possible to work on the labels.
Oh, I have heard of X-Array. Yeah, I remember this.
Rather than going through numeric indices all the
No,
time,
and
always mapping in and out of ints.
And Thomas, I completely agree with you. Like the enum type class usage in your arrays in Silene, I was like, yes, that's exactly how you should do it.
Iota and tau.
Yeah. Okay, so I'm reading lean calls right now. Data transformer slice. Multi-bag. Why would you need a multi-bag for slice? Sorry, now I'm getting into the weeds of this.
Right. I'm just looking for. You said what was it in a test file where you can find an n-dimensional tensor thing? Index notation. Okay, well that's convenient.
ND array.
Alpha and iota, the two most intuitive types.
Indexed ND array. Two multiset. Oh, why would two multiset be that primitive though? Like, I get that it's like a function that would be nice, but why do you need it when you make the instance?
I think he has just like multiple layers of abstraction, and multiset is just, yeah, so any matrix effectively defines a multiset, right? Where you kind of collect all the elements of a matrix,
Yeah,
right? Like,
of course.
yeah,
I mean, that makes sense, but it's not like my question was like, why does it need to be so primitive? Why do you need it to be? Maybe there's an efficiency gain. Yeah, no, there's like for sparse matrix representation, I can see a multiset being extremely useful.
No. I think it's generality, right? So certain he wants to kind of support different objects that they don't have such a structure. So there's like some multi-set object, which is probably like the basic things you can probably just fold over, and that's the only thing you can do with it.
Yeah. Cool.
Index notation. Private partial def. I think they work. Partial private def would be a bit confusing.
Yeah, it would.
Oh, partially because it doesn't have it probably uses recursion, but I didn't.
I mean, if the order was different, it would be partially private, partially public.
Yeah, partial private would be worse. Yeah, but yeah, so private partial is better. Okay. So this is
Assuming the expression is some product, turn it into an array.
yeah, great.
And you can provide the expected number. Oh yeah, question marks are valid identifier syntax.
Is that for options? For optionals?
No, it's not special. It's just like using a prime in Haskell. It doesn't mean anything special.
Oh, right. It's just a question mark. N? Option?
N?
Question mark?
Return none if n is empty or if
Great.
doesn't make sense.
Well, I need to see the lean calls array to see like now I just want to like race to like the easiest like MVP, you know?
Well, yeah, that was the idea. like a raw data representation. Just look at that.
Maybe, or
Well, not too raw.
no, not raw, but like
Not like byte level raw.
I want to see what the exactly. I want to let's do Einops on the. Let's do repeat.
On the def of ND array given.
Yes.
Okay.
What do you mean by Einops?
Oh, sorry. Einstein notation is the standard like thing that
He knows
apparently Einstein used.
Yeah.
Apparently,
Yeah,
but it's
yeah,
really
I know.
popular in ML right now.
The Einops is a popular library that takes the einsum operation as its primitive, and it defines 3 new functions of rearrange, repeat, and reduce that all are einsum under the hood, but it just gives them clearer names and a useful restricted usage. It also has like lots of little niceties in the syntax like this, like here.
Here, let's actually go. Here, you see our example. Repeat x. That's an example from Python.
Yeah.
So what that's a 1D vector appended to itself.
Yeah,
Right.
the parentheses mean implicitly collapse this into one dimension by multiplying out the elements. So this be a dimension of size 2i.
But I actually don't know if that's like XXIIZZ or if it's XYZ. I actually don't even know. I don't know enough about Einops to know the difference there. But I know you can do both with Einops depending on how you do it.
Yeah.
Like there's a different way of, there's one way of doing, this one does it one way and there's another way of doing it the other way.
Yeah. Rearrange, which we're not doing, is probably the most popular one.
Yeah, rearrange, that's like the generalized notion of transpose, is where you get into like,
I mean, it's what it sounds like.
It's
Which
what
is
it-
why this is a useful library, because you don't have to explain really.
yeah, so what this does is this transposes the last two of the, so this is rank 4, you take a rank 4 tensor, and you do a transpose on the last 2 dimensions of it. That's what rearrange with this string does in Python. We didn't even write these as unit tests because we didn't give like example unit tests for these. We just like wrote the syntax we wanted to support. Yeah. So that's what Einops is. It's just a really popular ML library right now.
Yeah, I think like a bunch of this notation already, you can do it in Siding. I just need, I think I can show you how to do it. I just need to
Perfect.
get non-broken version of Siding working on my computer.
But you're saying it might be worth just doing it for end calls, so let's do that while you struggle. Test one. What did that do? Port. And then open it.
You deleted it. Oh no, it's not deleted. It's just collapsed. It collapses all your imports.
Yeah, this is also not the file I want to do it in anyway.
Oh, that's right.
Oh, it's almost done actually.
Yeah, and I'm just monitoring the uptime here of the stream.
I'm not using iota though.
No, it's fine. Is that an iota?
It's going to be called index because it is an index.
I like X instead of alpha. To me, alpha and X are like the same.
No, I'm against this. I've thought about my default variable name a lot.
Okay, never mind. Don't worry about it. I don't care.
No Leibniz, you are. Okay.
Okay, so you have a nice syntax where you can do. I mean, in lean calls, I mean you're offered a syntax where you can just put in tuples, or you can put in like the commas in it, and it'll work for both. So that'd be cool to study the macros.
In this case of Thomas, in this instance of indexed, is it just use? Oh, never mind. No, it's not calling out to anything. Wait, will this even do anything though?
Presumably not, since it's all sorries.
Yeah, you have to implement all the get update of fn fold. I think you can probably leave out.
All right.
Probably you cannot leave out the.
What is mem? Like mem set?
Yeah, probably mem you can. No, but because then I think the compiler will complain that it's non like it has stories and it cannot compile it. So, but I think like for mem you can probably just write true or something because it's just expecting some prop, so you can kind of give some nonsense for multiset. You can probably just default like say default or something. What's the expected type? Yeah, so it's expecting something A and then, yeah, expecting element, then the array, and then it's expecting like a prop. So you have to say like function underscore underscore assign.
Oh. Assign?
Yeah, underscore and then capital 2. Oh no. Instead of assign, just say true.
Oh yeah. Mem fun to true, yeah.
Oh no assign. You just need to create whatever prop. Yeah, and then just delete everything.
Right.
Yeah. It's just right. Mem is a proposition telling you
Yeah,
that
the
the element is really something is an element of an array. And like if you don't care about the correctness right now, right, you just write true that like, oh yeah, you can write false, whatever. Such that like, yeah, whatever, anything is element of that array. It will not be used just for basic computation right now.
Let array equals any array. I get the thing out there. Type is not the. Oh.
It might be the underlying list in lean calls has its like fold L in it, and you might need to call that.
There's an array.foldL and a list.foldL.
Well, what does collections need? What does collections want here? It wants index type array. It wants array.
What I really want is to get this array out.
Oh yeah. Oh,
You
Yeah.
get that underlying array just by typing .1.
Oh.
So and the array .1. Or .val, doesn't matter. Yeah.
Neither works. Or C is a constant.
Wait. Did you write it in the right order? Yeah, and the array has type beta. It doesn't have a type in the array. I think you wrote
The fold in the wrong order.
yeah, I think you wrote it in incorrect order.
Oh yeah, that makes sense.
Okay, so it's supposed to be the data type, then the function, then the init. So completely the wrong order.
Yeah, it should be ND array F and then the initial value. Yeah.
And I can't actually
And then you can just
do inline.
Ah, R dot phone. Yeah.
and then you just fold over, yeah, and then you just yeah.
No,
This is-
you can't go totally point free.
I just wanted to know if it would look alright. I'm not gonna do that.
Oh wait, so that'll infer. You can still do. It's like kind of point free, but it's literally a point, and it just infers what just gives it like an arbitrary name.
I actually think this is pretty readable, honestly.
It is pretty readable. Yeah.
Okay. What does our function do? Form an instance by specifying its value of every index.
Okay, so you can just do like. You, I think
Figures
it's.
have spoiled me. Yeah.
I think it's just like.
Like map the array.
No, it's simple. It's just you just give it arbitrary data. Right.
I thought it was to transform it into something in particular.
Did it work?
I just deleted the thing. Now let's do get, because that one we really do need.
Yeah.
Get takes what? Takes an index.
Okay, so to do get, should it be
Okay, let's do this.
what's that center dot or C dot in how do you type that C dot in? It would be C dot in LaTeX, whatever that is.
Yeah, what is it or what does it do?
Or how do you type it?
Backslash dot.
Oh, backslash dot.
Otherwise it would be very annoying to use.
Yeah, it would be.
I think it's a little too clever, because these would be different. Like this is like A plus B for arbitrary A and B.
Yeah.
And I like what Swift does with like the dollar. I know the dollar signs in Lean are taken for other stuff, but this it's not the most pretty.
Yeah, I hear you. But that's fine. That's not a huge deal.
Also, wait, why is this even called get? Shouldn't it just use the get element type class?
There was some objection against that.
Why?
Because it has this huge domain thing, I think. There's like the idea is here you can index really with only one type. With the get element notation type class, you can index with finnn, but you can also index with anat, providing proof and stuff. I don't know. I think this is still up to debate whether it use it or not.
Okay.
I can imagine situations where you might want to roll your own get.
I definitely ran into the issue that exactly that the get is kind of too polymorphic, and it kind of trips over some stuff. So,
So you do the exclamation point to say, I don't feel like writing a proof that this is fine.
yeah, I don't write for this most of the time.
Yeah.
Right. Index. Yeah, what's this? Inhabited, really? Inhabited. Now what? It has type argument index, has type index, but we expect it to be a nat.
Because array.val
Yeah,
is
yeah.
is the underlying. So just
Well,
do
yeah, yeah, yeah.
do an
So
upnet.
exactly. So here you need to convert because IDX, right? Oh,
Yeah.
you're overloading you're
Upnet.
shadowing the IDX notation, right? So you have IDX for the type, and then IDX for the index.
$sign.
Um, so
Nope.
what you need-
Dollar sign on the other end.
There isn't even an add mat
no,
function.
no, 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 no. You need to use the index. So you need to the index type. So this is exactly right.
Oh, this is index type dot ofnet.
No, this is index type dot to fin, I think.
Index. Index type.
Yeah, index type. Oh no, without ed. No. It's just index type. Yeah. Remove the index.
No. From fin.
Oh yeah, from fin.
From fin to fin. Nice. From fin.
Yeah, that makes sense. That makes perfect sense.
It has to be to fin because right now you have the structure index, and you want to turn it into the linear index. I think it should be to fin.
The type checked and the other one didn't.
Yeah.
The type checker saves us
Because-
again.
Right. You have this underlying data structure is this linear array, but someone is giving you the structured index, and you need to turn it into the linear index.
Yeah, that makes sense. Julia has a name for this too, like Cartesian indexing versus flat indexing or something.
Ah, yeah. Well, Cartesian indexing invokes that idea of like doing arbitrary tensors where every tensor is rank 2
Yeah.
because of like a con cell kind of vibe.
Mhm.
That's what to me what a Cartesian indexing evokes or connotes. Are we gonna need
Update.
probably with a do block, right?
Yeah. Let's see. Update. How did you name it?
This is good. This is how we're gonna generate data to make unit tests out of.
Fine.
Update R
Okay.
IDX. Yeah, X is I is fine.
There, much better. Up.
And then you just have now you have Rust. I mean, id.run do is like it looks exactly like Rust. It's ridiculous. Well, no, it's not. How would it be let mute x's or like let mute x's prime equals x's? There's no way that's gonna give you anything.
The error is because it's returning that implicit lane.
Yeah.
There, see, that works.
Yeah, but does it do what we want?
Well, we're going to do this now. It's like for x in x's.
You just didn't. You could just write Python in an id.run do.
Yep.
This is like the best proof assistant ever. That's ridiculous. That should be illegal. Oh my god.
Why? This is like the thing we were talking about last week where people just, like in The Matrix, where Agent Smith is monologuing and he's talking about how in the first version they tried to make it a Garden of Eden, and he's like, it was a disaster. No one would believe it. Entire crops were lost.
I get it. Yeah, you have to look it
Because
up.
people just define themselves by suffering, because things being too good is like wrong somehow.
This is how I feel about the computer. Okay, so
And yet you have 64 gigabytes of RAM. That's an optimist.
that's true. So let mute x's equals x's. But wait, what's the new data? What's the new information at the I?
I don't know, I just sort of make this out of habit. Let's see, update It should just.
How do you
Like,
up?
we could probably.
What do you
There should
update?
be-
What do you
wait,
put it in?
There might even be like an array, like x's dot val dot like set.
Yeah, it probably is. But like here, you're missing the point, dude. Like you can't just set with an index because that tells you where you're looking up.
Yeah.
You need new data. So should there be another argument?
Yeah. Let's see. There's the array. There's the index.
Why does
and then there's
update
a
only
value,
have 2 arguments? That's what I want to know.
Because I forgot to write one.
Oh, well, there you go.
V is a typo.
Do you need alpha, even though it's in curlies, so it should be inferred? That's how cock works. I'm just
V has
assuming that's
type
how
A
works.
to A, but it's expected to have type A. I might have just written the arguments in the wrong order.
No, that's you're missing an argument, dude. Maybe the type that
X,
is curly
Index.
needs to be given explicitly. The type of V. Whoa.
What?
That's a nice little syntactic thing that Lean lets you do.
Yeah, this isn't it.
Oh, Thomas, do you have a view of like, do you know Flock? The IEEE.
No,
You've,
I
ne-
know it exists. I've never used it.
you've never looked at it? Okay. Because
Apparently
like
popular in my social circles. This thing I've never heard of.
I was wondering like what the state of some of that stuff is in Lean because Flock like gives you what you need to then do what a later library called VC Float did, which was to actually like do like the standard quantification of relative and absolute error from numerical analysis with like strong type theoretic proofs. So that's like something that I was thinking about with scientific computing, and like I was wondering like where Lean was with that because the story is like Alok kind of got me to migrate to Lean like in the last like week, but I've been like in Coq for like years, so like, but now I'm just starting to migrate some of my starting to migrate some of my thinking into Lean. So I was wondering like what the underlying IEEE 754 support is like.
Yeah, like on formal side, non-existent. I think like one guy now is working on making formalized pictures of Mandelbrot set. And I think he's using interval arithmetic or something like that.
Using what?
I think he's using interval arithmetic.
Oh, interval arithmetic. Okay.
Yeah.
And is that's in MathLib or is that in a different part of Lean?
I think he's porting some stuff to MathLib, but he has his own repo.
Yeah.
That's I don't know. Yeah, that's one thing I'm not really even looking into the floating point. I'm kind of looking more kind of the high level mathematics.
Yeah, for sure. Well, I noticed your examples. It's all very like physicsy.
Yeah. That's where I'm kind of coming from. So.
Yeah.
Grinding through a couple of the lower level stuff, especially like GPU and like say float 16 support, that would be very useful.
Yeah.
And in particular helps with doing the high level stuff by making it usable now so that people can give it money instead of at the end.
Yeah.
As is like the risk with a lot of mathematician projects.
Sure. Also, what was I just about to ask? Do you know about notations in Coq? Like the notation, the literal keyword notation?
No, I've used Coq a very long time ago, so I don't remember anything.
Okay, because I was like kind of thinking there's so much you can do. You can be very, very expressive, but I don't really know yet how to accomplish the same amount of expressiveness in Lean.
I would say like okay. My expectation is that you can do whatever.
Yeah, I
In
think
the
he
beginning,
expects
when
us
it comes to
to.
notation. It's
Certainly if Coq can do it.
Yeah.
Like, I've never used a system as extensible as this.
So I don't know. Like, what would you like to do with notation?
Oh, I would like to just think a little bit about like, like, kind of like DSLs for neural networks and stuff like that.
Mm-hmm.
And thinking through like the types of stuff that people like to get out of PyTorch, like how much could you replicate that in this environment? Not that you really need to, because actually like the type checking in modern Python has gotten like pretty darn good. And it does basically everything that I would want out of this. So like it's maybe more just like a curiosity or like a motivating kind of jolts of a curiosity than it is anything else, I guess.
Right. Yeah, I don't know. I don't have that much experience, almost I guess zero with PyTorch, so I don't know. I would need to see example of what you have in mind.
Yeah.
Right.
I don't know. For example, I wrote in Lean like a sketch of a neural network, and you can like write it really easily. So it's very beautiful.
I read it. Yeah, I definitely read it. It was super super readable, and I just wonder like, I like it a lot. It might just be like. The things I'm thinking about are like, okay, what about recurrent layers? What about like attentional layers? Like things like this. Like, what if I want to manipulate the residual stream more? Like which is more in the weeds things about like modern PyTorch programming.
Mm-hmm.
But basically, like a sequential model, like you're right, like your syntax in that example is like. The ideal sort of, but like it's not like that conceptually different from what we already had for sequential models. But the real question is like when the models aren't like entirely just like sequential models. Like how would you put like in skip connections in that syntax?
How would you put what?
Skip connections? Do you know skip connections?
No, I don't know.
It's where you take the sum of an x and then a layer at that x. So it's like x, if a layer is f, or like a composition of layers is x, or f. If a layer is f, this f that Alok just wrote, or a composition of layers is f. Maybe an AC art will show us skip connections. Why not? Because we live in the future. That's a skip connection.
Yeah, it's just, it's no problem.
Yeah, I guess that would be no problem, wouldn't it? Because it would be slightly harder than just the arrows that you showed, but like slightly more vocabulary than the arrows you showed, but like not like outrageous to pull off. I agree.
Because you can write like any lambda expression, right? So this is definitely within the realm. Right. And I think like for example in the example I wrote for the neural network in Lean. Because it's really just a lambda expression where you have like explicit, for example, the weight.
Yeah.
You can easily, for example, apply the same layer with the same weight. You can, for example, reuse the weight in different layers, which I don't know if it's of any use, but from what I've seen in all the frameworks, you cannot do that because the weight has kind of really kind of hidden part of the data structures you're operating with. So in Lean, you're working with the kind of raw lambda functions, the raw functions themselves. So.
Yeah, I hear you. Did you fix update?
No. So I'm trying to figure it out.
Val.set, basic application type mismatch. ID v, argument v has type A to A. Oh! Hold on, wait, go to the end of that line, please, so I can read it. Why id v? What does id do it?
I was just messing with it. This doesn't do anything.
Yeah,
But
it
why is the
it
type
should-
of V a map from A to A? Shouldn't it be?
Because, wait. No, just look at the update signature. So something that I run into in Cockabunch. Oh, no, it's a transform. No. It's the function that transforms the old value into the new value. So instead of saying like my old value is 1 and my new value is 2, say my value is lambda I plus 1. You know what I mean?
So in this
It's
case,
a
I would just like set it to some const if I wanted to set it to an
No,
actual value.
do replace v with f, and then do instead of v do f of no parentheses are before the f, I think. F of x's dot val dot I, not dot I, but lookup I. Or you might have to do get, right? Is it? Are you sure it's not dot val dot get? Dollar, yeah.
No, this get.
Yeah, you want to call that get if you can. Do you have that in type class instances? You should. You should.
Yeah.
It's a full type theory. I mean, there's no reason you wouldn't.
Okay, how do I refer to it then? Index to dot get.
Nah, that wouldn't work.
Whatever. I'm willing to just do the coward's way out and just copy this, really.
Yeah, me too.
So can I jump in and
Yeah.
maybe show you what kind of Einstein
Yeah.
kind of index notation? I
Absolutely.
already
Yeah,
Do you
sure.
want to share your screen?
Yeah.
Yeah,
If you
yeah,
use
yeah.
VS Code, you might even be able to enter this and type in directly.
Yeah, they have Teammate for VS Code. And I'm sure they have that. I'm sure you can probably Teammate from a regular terminal into someone else's VS Code.
Or we just do this.
Yeah, we can just do this. This is better. Can you make it bigger? Oh, that's right, because you use Emacs.
Yeah.
Dude, I use
Okay,
Emacs
can you-
too.
Okay, so
Instance
Oh.
array type notation.
this is I haven't used it for some time. So yeah, so for example, right here, I'm creating a sensor of rank 3, right, with
Yeah,
with
3,
dimension
4,
3,
4.
4, 4. Here I just create a matrix with by 4 dimension, and here is a vector with length 4.
Yeah, I remember your boxy notation.
And
showed it to
then
me
I
last
can
time.
just do matrix multiplication this way. Then I don't know, here is some contraction, right? So I just like sum over the last index. So I just say sum, but here I'm just creating, I'm creating a like rank 2 tensor with ij, and I sum the last component here, and I just effectively reduce the rank 3 to rank 2. I can contract the last because the last 2 dimensions, they have the same. They
Yeah.
have the same size. Then you can just contract them, or here I don't know, just take kind of the diagonal of the of the last 2 dimensions. So yeah, I don't know. This kind of notation you can already do.
Oh, that's great. That's like almost everything we wanted to accomplish, isn't it?
That suits me fine. It would be like it would just be an additional layer of wrapping on top of it to basically implicitly create the sums and stuff.
Yeah.
So that's one thing, right? Like in the standard Einstein notation, right? When it kind of detects the repeated index, it will automatically kind of sum over it. That's definitely not there, and that's probably some fun project to kind of play around with the macro and notation, to kind of, I don't know, look at this piece of a syntax, find identifiers that are currently not really kind of used or defined in any certain way, and then find out if they're twice or something, and then try to put the sum somewhere in the correct place.
Yeah.
So I'm not sure if it's really that necessary. Is it like too much of a hassle to adding the sum there? But I don't know yet. I don't know.
Well,
If you
that's
go
how
to
one
different
learns.
geometry, then then maybe like writing the sums everywhere is kind of tedious.
Well, the thing about Einstein notation is like conceptually it's kind of one thing, right? But notationally, there seems like a big unexplored space. Like this is one option, the Python version is another option, and like I would want to play with like more options to like see what you can do, and also it's a good excuse to learn macros
Yeah.
and syntaxes and notations
Yeah,
and lead.
Yeah,
So
I
maybe
think
what we'll
you can
do-
play around a lot.
So we just import these two things and open Silene, and then we do box plus and we do sigma.
Yeah. So right now, if you're on the master branch right now of Silene, it does not use lean calls yet, and right now you have to put these nasty brackets. So you use a square bracket, and then you have to right now do the like a curly, like a normal bracket. The
Yeah.
index notation. I fixed it in the lean call, so you don't have to do that anymore. But it's not fully functioning everything yet. So, yeah. Yeah. So yeah, like with the master branch of Silene, you can just do this. I think maybe I don't think you really need maybe just need this import. Yeah, this works.
In retrospect, I should have just asked you to copy the code instead of doing this.
Okay, Alok literally
Yeah.
can you believe what Alok just did? He took a screenshot, uploaded it to DALL-E, to ChatGPT, and asked it to transcribe the screenshot.
And now I'm gonna have it fixed at the box pluses.
Did it work?
It actually, yes, it worked, I think, but you could have just pasted us the code.
Yeah, I did it on Glib. I did it on Glib. Oh, I did it in the right.
Force of habit.
Is there anyone? Can we check chat to see if anybody showed up?
No.
No.
The opens have to go after. Alright. Like,
Oh yeah. Let's hope we don't crash. Cause okay, Silene was like crashing cursor earlier though.
I think it's because we were modifying it.
It's because we were modifying the .lake file, right? That's probably why.
Not the lake, the source code and packages.
The source code and packages. That's what I mean. Not the lake file. The .lake version of the repo.
Okay, it's compiled. That's compiling quite fast though. That's just in standard.
I think you have to write the address with capital S and capital L. Or is
Not
it,
in here. No.
Our pages case sensitive? That's what not right. Oh, so it's fine.
If you look at your own package declaration and lake file, it's in all lowercase.
I see.
Because like the repo name. Maybe it doesn't matter though.
Like everything, Lean gives you the option to customize it. It mercifully doesn't make you. They also do the rest thing. If you use dashes in the file names, it will just use underscores.
Oh, I think you are rebuilding the whole maplet. You should not do that.
But how
Oh,
am I
you-
rebuilding all of
Wait,
Mathlab?
are
Like,
you?
what am I doing that would cause it?
No. Okay, no, it's fine. Okay, I don't see really what's going on in the terminal over the picture of you two.
Oh. Well, the terminal's empty at the moment.
Yeah, I see.
Let's get up here. Unknown constant, funlike.coercion.
What are some other ways you would notate Einops in a computer?
Silene tactic F trans init. Hey Thomas, you see this error?
I think, wait, data type is not a thing, but, yeah.
Data array. Oh,
Data array type.
Yeah, okay then.
Way to go, ChatGPT.
That was me actually.
That was you?
Yeah, typing.
Yeah, the error looks weird. It looks that.
It looks like it's about to resolve itself though. Or oh wow. Yeah, same error.
Are you sure? Are you on the? Oh wait. I see.
You know what would be cool?
What?
A combinator library to do the IDX combinations. So if we start with IDXs are just enums,
Yeah.
right? Then what we can do is we can do like, this is on 10% battery.
Just look for a charger.
Yeah, that's fine. We can just lose maybe we can just lose the sketch pad. What?
I mean, I guess it's like you could lose a younger brother, but you wouldn't want to.
Yeah, let's see here. Yeah, a combinator library that can combine enums into like the product of enums and stuff like that. You just like set up all the algebra to do what Einops does under the hood.
Hang on.
Okay.
Why is this all saying version?
That's already there, right? If you have two types that are like in type or like the index type, and you take a product of them, it creates a new instance that the product is of index type, and then if you take a sum of two types that are index type, it will create a new instance of index type, such that it kind of correctly linearizes the sum of the product and all the algebraic operations you can do.
That's certainly true, but I'm wondering how well it works for repeats, and I'm wondering how well it works for like setting up like, or I'm wondering if you could make it better for working if you're doing like high rank like transposes. You know, like I'm sure it's all there, but we might be able to make the reasoning a bit easier.
So, yeah, I think like the only the compiler error that was there,
Yeah.
I would just probably do so maybe like update the Silene to the newest.
But
I know that there was one thing that was definitely will be buggy, so I fixed that. So if you update Silene, so
But
if you
isn't this
right
updated
today,
look? Because it's taking from the master branch directly from Git. Shouldn't this just be the latest pull?
Yeah, I don't know what was in your lake manifest, which might be older. So I think if you do now
Revision
lake
29.
update Silene,
Older than
So-
like a couple hours ago.
I don't know. Yeah, then it's weird.
Fixing. Older than 2 minutes ago.
Oh,
Okay.
you just yeah.
No, I fixed one thing just now.
It's the
Uh,
one. Okay, the one I pulled is the one just before that. Also, can you bump this up higher than lean version, like 4.5?
I'm working on that. They made lots of changes, and like I'm working on it for the last month. They completely redo the simplifier.
Oh, the
Uh,
Simprox. How are those, by the way? I was wondering. Was it worth it?
Oh, it's cool. Yeah, I'm using for a couple of things, and it
Like, what does it let you do that was hard or impossible before, or
It was
infeasible?
not impossible, but effectively, yeah, I had to hack the simplifier, or like you had to strip out loads of stuff out of the simplifier that was already there. You plug it in, and then you had to put like all the packaging on the again.
Okay.
So like yeah. So like the core mechanism in the simplifier was sort of there to do this stuff, but do it as easily as it's possible now. It was definitely not there. And there are probably things that I don't even understand that are much nicer now. But,
I was just thinking the implicit arguments would be handy for passing around keys from PRNGs like Jax does. Otherwise, you always have to carry around the key argument.
That's yeah. You would definitely if you were.
Yeah, you can use implicit for that.
But you know what? Yeah, I mean, that would be great. But also, like, it might be easier to just spoof implicits in Python with like global config variables or something
Yeah.
than it would be to
This is not as meant as like a competition to Python.
no.
Like if anyone competes with to use this, it'll be the machine, not the human. Certainly not the human.
Sure.
Here, I'll update the manifest nonetheless to pick up the changes such as they are. Didn't work. Apparently not. Oh, goddamn. Same error.
So wait, when we try to import both, I feel like when we try to import both Silene and lean calls,
It's not that way anymore, look. I took out lean calls completely.
no, this is weird.
now it's just weird because earlier we had Silene built and like working. Or did we though?
Yes, we did. That's a whole lot of high rules. Is this, by the way, is this the kind of stuff that you can use Simprox to simplify?
So like so you have lean calls and Silene in the same project, right? Now.
As dependencies, yes.
Yeah, and that's the problem because I think lean calls right now is on the 4.6 version.
Uh,
Yeah. I think it bumped you. I think maybe it bumped you to a wrong version.
but look, it says that it's building with lean toolchain 4.5.
Oh, okay. Or maybe pick the wrong version of Mathlet.
Lake packages. It says it's in, yeah, here in Ftrans, where this is just unknown.
Yeah.
Funlike is no longer, of course, co is conversion, but coercion. Same thing.
Yeah, this thing they renamed to dfunlike, and that's the issue. I think you must have like the incorrect version of Mathlet. I think one safe, like easiest way to fix this is sort of like wipe out the lean calls dependency.
Oh, just delete the package thing.
Run
Lake.
run lake clean. Delete manifest. and then probably to download the cache again. And I don't know. This dependency is a mess, and I always run into issue, and I just delete everything and then just rerun like completely clean.
Warning. So Lake manifest.
And
Okay,
maybe
better.
also remove the lean calls dependency from the like file,
Yeah.
because that might getting a different version of Matlib, which would not be friendly to Xylene right now.
Mathlib so big. I wish it would use some sort of cache.
Yeah, I mean,
It's like
ideally-
every project pulls Mathlib at some point, and it's 4 gigabytes.
Oh my gosh. Yeah, we should be using a cache. I mean, Cargo would use a cache for that.
Yeah, but they didn't initially. It took them a while to get there.
Yeah.
The chickens have come home to rust. No files to download. Decompressing 4100.
Did you guys use the programming language Dex developed by people from Google?
No,
Yeah.
I haven't heard of Dex. I don't
Really? Dude, you've hung out with people who've worked on it.
think. Really?
Yeah,
Oh, Jax. No, Jax.
Dex is related.
Oh, Dex is related to Jax? Yeah, I know Jax. I have hung out with someone who worked on Jax.
Yeah, so I think some of the people working on Jax are working on this experimental new language Dex.
Working as in last commit was last month.
Yeah, hold on. Let me see here.
And then
Let me see the
like-
README.
Sure.
Type system for array programming? Yeah. Well, do you know Futhark?
Yeah, I've never used Dex either Futhark, but yeah, I think they're kind of similar. But
Look at the serpency
I think
triangle there.
Futhark does not, because Dex has some version of dependent types for the effectively for indexing.
I wonder what they would make of Lean, since now you... The stuff that's like partially dependent type seems to go more and more in that direction anyway.
Yeah.
That's the danger of like adding a type system that you want more and more, and then you just get to swallow all this complexity,
Yeah.
or you could just like crash in Python.
I kind of want to try monologuing about something. If you like, hold on,
Sure.
wait. I have 8%. Hold
Okay,
on, I'm just gonna charge this bad boy
Sure.
because it's
So-
USB-C, right? Unlike your phone.
Yeah, it is C.
Great.
Feel free to monologue. Let's hear it.
Hold on, let me plug in the thing and then.
I'm looking forward to this. Some prime monologuing.
Oh, where did I put that charger I had? Oh, here it is.
The lighting really is perfect.
The lighting is so perfect in here. This room is so amazing. Alright, so I want to think about Einops as a programming language, where there's an evaluator and there's an executor. Well, maybe there's not even an executor is the thing. In fact, fuck execution. There's gonna be no
I
execution.
think of it really as like a purely syntactic transformation into the familiar form, because like even Einops itself, the real one, just dispatches to einsum, and it's just formatting things to turn them into einsum friendly formatting.
Mm-hmm.
And that seems like fine, because we can implement an einsum.
Oh yeah, you can implement it, but I still just kind of want to. No, can you share? Can you put put this thing on the screen?
Let me think.
Oh, did you kill it?
Oh, the freeform. Oh, that I can easily put up.
Yeah. Then scroll down. Scroll down until you get to the inductive. All right, here it is. All right, so like if you think about Einops as a programming language where the nodes of the ASTs are all like, hold on, wait.
Wouldn't it take an array and a list of enums and then... Oh, there, yeah.
Almost forgot.
Oh,
The
actually,
output
no,
type.
Actually, in Lean, I don't think you need that.
You don't even need the output? Well, no, you do
no,
because...
yeah, in this case you do, because
because
it's
it's
not
an
returning an
inductive.
Einops. Yeah, it's
Because
not
it's
returning
an
an
inductive.
Einops, yeah.
Um,
Yeah, only in the case where it's implicitly itself of type Einops.
or, in fact, this is actually wrong, because it's not returning an Einops, you're right. It's like there's an ein operated array. Here, in fact, I'm just going to do this. Ein operated array is, but this is ein operated array, 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 and then there's a lift array to ein operated array. That's how you would do it. And then what you would do is you would write your evaluator, which would take a term, take a term of type ein operated array, and then like if you could unify like the application with here, forget all this.
Like parsing an application.
If you could unify the application with a normalization, a notion of normalization, right?
I would rather just do them separately unless there's a real advantage to doing it in one.
Well, I'm exploring. Hold on, give me a sec.
Fair monopoly.
The reduce, repeat, rearrange, lift. No, because normalization's pretty trivial because all it does is because there should be a way to just extract an array from an EO array. I'm just riffing here. This is pure riff.
Here's how Einops does it, so I'm gonna take a look.
You want to read the implementation?
Yeah, since I suspect because it's in Python, well, it's not gonna be more elegant. I'm not even sure it really could be. Like if it's some big ugly mess, then that's one thing, but what about the optimize? Don't care about optimizing.
Transform recipe, that's it.
What a mess. Alright.
It's just because the syntax highlighter doesn't distinguish comments very well.
Elementary axes lengths. Not including ellipses dimensions. We can leave out the ellipses. Mapping name to position. Really, that should be a bidict. Bidirectional dictionary.
Really?
Yeah, because it's supposed to be a one-to-one mapping. Because it's a finite set, therefore bijection.
Wait, hold on. But if you have your 0th rank is like 4, and your 0th dimension is 4, and your first dimension is 4, then 4 wouldn't be able to map backwards uniquely.
Okay. Each dimension in the input can help reconstruct length of one elementary axis or verify dimension. Then a permutation, first reduce, Jesus. Fake hashable axes lengths, cooked recipe. Yeah, this is it. Apply recipes where the parsing is like actually being fed in. It looks like it's mostly reconstruct from shape. Because then, once given that, quite interesting. It'll just apply them in a chain. Alright, this LRU cache reminds me. Hey Thomas, do you know if Lean has like some sort of LRU caching or memoization?
I don't know what that is.
It's like when you ever see the one where you write an implementation of the Fibonacci function in the naive recursive way, and then it blows up because you evaluate a tree. I can just show you the code if you want.
Right. Well, you can do. Wait, are you talking about the recursion?
No,
Okay.
I'm talking about when you have some function that's recursive that you just store in some hash map or something pre-computed results as they've been.
Oh,
Yeah.
yeah. Like if you look through Lean Core, this is done at multiple places.
What's it called?
Oh, I don't know if there is like a standardized way of doing this. Okay, let me check.
How's riffing going? Well,
Not
let's take a
super
look.
well. You can just look.
That's true.
So valid imps out would be a bool, would be a predicate that just like says if you're left of the arrow part and you're right of the arrow part if they're compatible. Like just a bool, and you would have to do a different one for reduce, rearrange, and repeat actually. But I'm thinking like and I also don't have a theory of how I'm getting out of an array because I want the eval to land in array. I mean you could make the type indexed on arrays, but I don't know if I want to. Because this would have to be some... It's not an inherently recursive structure, though. I mean, it could be at the level of the cons, the only tensor is rank 2, and some tensors have pairs as indices, Someone talking to us? Oh, it's Tom.
Thanks. This is where replace unsafe.
Ooh, the replace unsafe monad. I'm assuming M stands for monad and unsafe.
Yeah. So I don't know if is this is something you had that idea.
Yeah, I think this is about what I meant because it looks like it's directly writing to a cache
Yeah, exactly.
and then extracting it.
Yeah. And it's just the replace M is just a state. It creates a new structure it's called cache, right? Which has some stuff, but I think at different places maybe I can find one which
you'll like
is
this.
used.
Look at those little. Look at line 59. The outward arrow in the
Whoa!
It's like monad lift or something.
No way. Oh wow. Well, what it's saying like.
Get out of a monadic context.
But has result 4. It's just like it's just a nice easy syntax for it.
Yeah.
But why not just do and then let X.
It's equivalent to that. It's just to do it inline.
Yeah, but you're writing it twice. You repeat it. You're doing back arrow get dot hash result for E, so that you can return back arrow get hash result for E. So why would you want to do it inline if you're repeating code?
Wouldn't you just const fold it?
What do you mean const fold it?
Not const. Save the first expression, the whole has result for. Oh no, it's not. If has, then get for it.
Here, can you check the Twitch chat just in case someone joins? Oh hey, sorry for bothering you. I wanted to offer promotion for your channel. Oh no, it doesn't matter. Sorry to bother you. Just want to offer promotion for your channel.
That's why I swore at him.
Oh,
Because
you
they
did?
just put go to Steam Rise. Like I sort of read the entire thing in one. It's like this is an ad and
This is an ad, yeah.
This person's dead to me. Let me throw someone off stream. Whatever.
Doesn't matter. You probably can in Twitch.
Okay, replace unsafe. Oh, this is just doing it automatically. And replace expression. Wait. And a cache's size. Array of non-scalar. Either an expression or a disjoint memory. Okay. To do use the pointer address to avoid unsafe tracks. Implemented
I have
by-
no idea where I'm going with this. No, I would have some idea, but it would take me way too far afield. Like I would need to be like at my workstation in a fresh cock environment because I'm more familiar with it, and like I think I could go get somewhere. But
For all our build issues, how have you been finding lean today?
oh, it's there's been some really cool white flags that I've been excited about,
White flags? I've never heard that expression.
as opposed to red flags, or like green flags. No, green flags is the
Are you
expression.
red green colorblind?
No, I'm not. No. I just green flags is what I meant. Not white flag like surrendering.
Yeah.
I meant green flag.
Okay.
As opposed to red flag.
What the hell? And now it's fine? Okay, I guess wiping it did do something. That's reassuring. Okay, there, that's more like it. Alright, the index type isn't even in here. Nice little boxy syntax. Where were we?
I was just thinking through like, do you want to just try to see if we can write something that will like interpret strings from Python syntax for Einops, and turn it into like the syntax that we saw?
Sure. We could even, here, let's just start the simple inductive line up, which will just be reduce, repeat, rearrange.
That's how you do like sequences of nullary constructors.
Yes.
In terms
Very
of, in terms
esoteric
of the
way of
format.
putting it, but yeah.
In terms of the formatting.
No, I put them on new lines when I'm lazy.
Oh, okay.
And GPT will do it later.
Yeah.
For computer. Anyway, so that's an Einop. Parse ein expression. I'm just going crazy with the eins.
Mm-hmm.
Or means. I also like that when you end a namespace, you can say what it's ending.
Oh yeah, no, that's great. You need to do that.
need me parsing what expression to use.
And it should be a maybe too. Because
Like it's an empty string or something.
no. If it's an invalid one, like if it has an access given on the right that wasn't in the left.
Okay, here. What information should these carry?
Exactly, and so this is what I was starting to get into. No, it's axis. It's like left axis, right axis.
I can't just get up there, but I wish. They all are like that, right?
Well, they're not arrays of integers because they're arrays of IDX. They're arrays of labels that reference IDXs. But like,
Okay.
see, this is where you almost need heterogeneous lists because you can't say here. Can you go to my thing? Scroll down a little bit. You can't say like if I have class enum. You can't say list enum. You have to say for some A is a type. For some enum, for some proof that A is an enum, give me. I'm using curlies because implicit, right? Usually, I mean, this is
The type class ones will use square brackets. Which I guess are also
See, this is not enough because these are going to be the same proof of enum for every one, meaning the same actual enum for every one.
Like
so you can't
that value or the leading value is an enum as you peel off the list.
Well, you might get no. I mean, you would get a proof that the whole list, every item is the same, has the same proof of enum, meaning every item is the same enum. Meaning, we kind of need heterogeneous lists for this. But like, they're not fully heterogeneous lists. It's not like I need a number and a bool. It's just that I need one enum and a different enum. So I need like, I'm not going to whip out a heterogeneous list right here, but I would say it's like, I was just going to write a little bit, but that's fine.
I'm just kicking it off in the background.
Okay.
And telling it to implement an H list and seeing how it works. If it does work. Okay.
Like, you can think of it as this. You can think of it as list exists and fin n, almost. I mean, this wouldn't be it either. This would totally not be it.
Okay.
But
so
actually, no, this could be it. This actually could be it, but then you would just take or it would be like list. That's a dependent pair, so the second projection is the proposition.
Depends on the first one, yeah.
But it depends on the first one.
Yeah.
But list second projection exists and fin n. Right? This might actually be a sufficient data structure. Because no, it wouldn't be a sufficient data structure because you would have to quantify the n. No, you wouldn't have to quantify the n because it's in and exists.
Okay.
This might be a sufficient data structure.
Okay, how do I write that though?
What's the syntax for sigmas in Lean? There's a few different syntaxes for sigmas in. Sigmas are like not that popular. Pies are so popular that they get like sublimated into like 3 different things, and like you don't actually write the word pi. But sigma.
What does it use actually?
is what's the second element of the sigma? Is it type or is it prop?
It's fin n. It's type. It's fin n. It's type. Yeah.
Yeah, then you can just use the same thing as the for product because sigma is just a product. Yeah, it's saying you can just use a product. No, or I don't see. Yeah. So,
Oh no, wait. This is the type. List of pi2 of exists n fin n. I went too far again. My bad.
A list.
So you need to construct it with the first projection with the n, but you need to delete that first n when you actually make the list. So the type constructor needs the n, but the data doesn't need the n.
Thanks, Thomas.
Oh, thank you.
And then a list of these.
I hope it's a list of these in such a way that it's this dependent pair, and it's a list. Also, take the second projection of it though before you wrap it in the list. It might just be pi 2, but like Blackboard bold pi. From no, that's capital pi. It's a Blackboard bold lowercase pi. At least that was the syntax somewhere when I read it. That might have been Mathlib though.
That was from Mathlib.
Okay, what's the second projection? What's the second projection for a dependent projection?
oh, I think you can just write .1, .2.
Oh, dot 2? Okay, so is it 0 index or 1 index?
Oh, I think projections
one
are
indexed.
indexed 1. Yeah.
Projections are 1 indexed? Okay.
Awful.
Yeah, 1 index. Everything else 0 index.
That's why I hate it so much.
No, it's fine.
No.
No, but wait.
So this should get us a spoofed heterogeneous list. This should basically get us most of what we want out of a heterogeneous list.
Dot one.
Actually, just wrap that. Give that a what's the word? Def. What's the other word for def? Alias.
Abbrev.
Abbrev. Give that an abbrev.
Abbrev it to what exactly?
Axes.
Really?
Oh, I was right. Oh, I was absolutely right. That's exactly their notion of heterogeneous list is exactly the same as mine, except they don't delete the first element. Well, why would it be alpha? No, not alpha. You don't quantify that name because that name comes up in an existential.
You're going to have to walk me through that one.
Oh, this is a syntax sugar for existential. Do you want to go back to my keypad for the walkthrough? In lean, x of type A, beta x, is just a syntax sugar for exists x, beta x.
Oh.
I mean of type
Is
A.
it just using like this product has some specific form? That
If you
is
scroll
this-
down, it's what I just wrote. I wrote the comma prematurely. So it's just it's a quantifier. It is a quantifier, so it's not a free variable. It looks like a free variable because they're giving you a quantifier without making you type a quantifier. So it looks like a free variable, and that's why you're confused, I think.
Yeah. Okay. Well, we have an H list now.
Yeah, the X means that you don't have a free variable. I mean, H list. What I would really like though is to not make H list, but to make two different notations for sigma. Okay, so Thomas is in chat telling us that there's different notations for sigma. See, look, there is a sigma type. There you can actually type sigma if you want by REFL.
if you use the mathematical exist, then you get something that's erased.
Oh.
Do we deliberately want that?
No, you don't want type
Something-
erasure. Alok really likes computation. He doesn't believe in erasure.
I don't.
No, but like mathematicians really like erasure, right? Like
Yeah, I know. Yeah. Alok told me that earlier today.
so
That the mathematicians don't
believe.
believe in computation.
Yeah.
Yeah.
So exist, like the standard mathematical exist, then it would live like in prop. In Cork, I think that's S prop. Like the erase.
Yep. Makes sense.
Okay, an H list of what though?
It's not. It is.
That's
It's.
just an H.
It's just an H list, right? What
Oh,
we
yeah.
really want is we want to restrict. We want to do a version of this, a version of H list called axes, that restricts it alphas to enum. So it's not alpha is of type, but alpha is of type, and then is in enum.
Not this.
It's not that, but it's like I think it's alpha enum, alpha type, and then alpha is of type, and then it's actually not that trivial to do it in Coq because we want a type class constraint. We want to put a type class constraint.
On alpha.
No, not on. Yeah, on alpha.
Uh,
I think you can put it. Try doing type enum type. Okay, so it'll work like that.
I couldn't just do like this.
I don't know. Thomas just gave us something in chat.
Yeah, he did.
But enum type isn't the name of the type. Isn't the name of the type class.
What is it
Oh, enum type is the name of the type class.
though? Yeah, it is.
Oh, well, it is inside.
Because he opened it.
Because we opened it.
I still don't know how open, what it exposes exactly. Like, how flat does it make it?
And
Is
it
like export
exposes.
declarations are pushed to the top level or what?
It just top level. The top level of the module is pushed to the top level of your module, but then you still have to go into like the lower levels.
Okay.
I'll be right back.
Okay. I will also be right back in a minute. Yeah, I'll also be back in a minute. I'm stretching my leg.
No problem. See you later.
I'm gonna get another tea.
any chance could you restart the stream again? I think it has like 20-second lag again.
Oh, interesting. Because yeah, we can. Because 20 seconds. I mean, how can you tell it's 20 seconds? Because if you type a message.
So now you're walking. Now you're sitting in the chair.
Oh, but I was walking.
Like just now you sit down to the chair you're sitting in. So I can see you on the Google Meet, right? And
Yeah.
you
You can see me in two places, and you know that it's okay. Well, I don't know if we need to stop and restart. I mean, as long as does it look basically fine?
Oh, it looks fine, but like when you're talking, right, about something you're writing in some code.
Oh, okay. So it would help you.
Well, I hear you from two places, right? I'm hearing you from the Google Meet. I'm hearing you from the Twitch stream.
Yeah.
And yeah, the Twitch stream is super laggy, so I cannot really, yeah, I have to kind of guess what you're doing, and then later on I can kind of see it.
Oh, I see. Okay, here, I'm gonna go ahead and stop the stream and then restart.